Hello, in this problem we will be working on addition of vectors where in this problem we are asked to find the magnitude of the resultant force and the direction measured clockwise from the positive x-axis. So you can see that we have a 6 kilonewton force and a 2 kilonewton force with the directions as shown on the diagram. So we are going to compute this problem using breaking these up into their components. So by breaking these up into the components, if we're looking at this 6 kilonewton force, we will have its x-axis, x component, and we will have its y component. And for the 2 kilonewton force, we will also have its x component and its y component. Now you can see by the way I'm showing or drawing these vectors that the 6 kilonewton force has a negative x and the negative y, and the 2 kilonewton force has a positive x and a negative y. So if we were to compute the components for force 1, let's call this force 1, let's call this force 2, we can say that F1 is equal to negative 6 kilonewtons times the cosine of 60 degrees. So you can see this is the adjacent side, the x component. We could call this F1x and F1y. And over here, we can call this F2x and F2y. So again, force 1, we have negative 6 kilonewtons times the cosine of 60. And we're going to symbolize this by the letter I hat. This is showing us Cartesian form, where x is signified by I hat and y by j hat. So we also have a negative, I'm showing this in the negative direction, which is going to be 6 kilonewtons times the sine of 60. Now you can see that F1y is the opposite of 60, so we would be using sine. So throwing this into the calculator, you should get negative 3i minus 5.196 j hat, and our units are kilonewtons. Now do note, again, this is our x and this is our y. So force 2, now our x is a positive, so this would be a positive 2 kilonewtons. Again, cosine 45, which is, this is going to be the adjacent side, so it's cosine 45, I hat, minus, again, we showed this force, the direction of this force vector going down, which is going to be 2 kilonewtons times the sine of 45. And we're symbolizing that in the y-axis. Throwing that into our calculator, we get 1.414 I hat minus 1.414 j hat, and this is kilonewtons. So all we're going to do here is we're going to sum those. So negative 3 and 1.41, adding those together, we get negative 1.586 I hat minus 6.61 j hat kilonewtons. So this is our force resultant in Cartesian form. So this is in Cartesian form. Now if we were to go ahead and draw this vector that we've just computed, set up an axis. We're going negative 1.586 kilonewtons. So right here, we're going negative 1.586 kilonewtons. And notice I'm drawing or showing this force vector to the left. So I'm not noting that it's negative. It's noted negative by the direction that I'm drawing this force vector. And then 6.61 kilonewtons, we go down because it is also a negative 6.61 kilonewtons. So our force resultant lands up to be right here. So this is our force resultant. So when we draw these, we add these vectors up. This would be a 90 degree, of course, which we can use Pythagorean theorem to get the magnitude of the force resultant, which is going to be 1.586, that's negative, squared. Now, the negative is going to cancel out because we're squaring it, plus a negative 6.61 kilonewtons squared, and we have the square root of that. So the square root of that, the square of the squares using Pythagorean theorem, I got 6.797 kilonewtons, which is going to be equal to 6.80 kilonewtons. Now, again, we are asked to find this direction measured clockwise from the positive x-axis. So this is what we should be finding right here, that direction right there. Now, it's easily computed if we call this right here theta, where theta, we take the tangent of theta, it's going to be the opposite, which is 6.61 kilonewtons, divided by 1.586 kilonewtons. So here we're going to take the arctangent of that number that we're going to calculate, 1.586. We're going to end up with 76.5 degrees. So measuring this clockwise, we have this 90 degrees. We have this angle here we're unsure of. And this we just calculated as 76.5 degrees. So if we take, let's call this angle alpha. Alpha could be 180 degrees. And we would subtract what we just found, that's 76.5 degrees, which comes out to be, plug that in real quick, 103.5 degrees. So our final answer here would be the force resultant is equal to 6.80 kilonewtons at 103.5 degrees clockwise from the positive x-axis. That would be our answer to this problem here. Now in the next video I will show how to compute using trigonometry, using the law of sines and the law of cosines in order to solve this problem. Thanks.